Good morning, students. In previous class we have been discussed regarding the distance and displacement and then with examples. Now we are going to discuss one more physical quantity, that which is nothing but speed. So speed. So how we can define the speed? Here as the rate of change of distance. So it's called speed. So rate of change of distance. That in general which we can write here as speed is nothing but speed is equals to distance by time. So distance by time. So this is a simple definition. So based on speed. So whenever if you know the speed, so which we can express here as SI unit. Here SI unit of speed. Distance which we can measure in terms of meter, and time which we can measure in terms of second. In simple form we should write here as meter per second, or if this second moves in upwards in direction, so we can tell here as m is to the power of -1. So both the cases are correct. Meter per second or m is to the power of -1. In the same way, so we can tell here as CGS unit. CGS unit in terms of centimeters, grams and second. That which we can tell here as centimeter per second. In short form, we can tell here as this as centimeter per second, or we can tell this as centimeter is to the power of -1. So based on this, we can tell here as in terms of dimension formula. This dimension formula which we have been studied in first chapter, units and dimensions. Based on this dimension formula, so dimension formula. This dimension formula in general which we are representing in terms of m, l, t. Here m represents mass in terms of m, l and t. M represents mass, l represents length, t represents time. Here small m represents meter. That means mass is 0, m power 0. Meters, that which is nothing but length. So l power 1. And then second, which is nothing but time, t power -1. So this is the dimension formula which we can be represented. So and with the help of this we can tell here as speed is a scalar quantity. Speed is a scalar quantity. That which we can tell here as speed has only magnitude but not direction. So these are some cases which we can express based on speed. So now in this speed we are going to discuss some types of speeds. So based on this we can express. So So if you have been taken speed, the speed in general, which we can classify into some types. So first one is average speed. So average speed. So next one is instantaneous speed. Instantaneous speed. Next one is the uniform speed. So uniform speed. The fourth one is a non-uniform speed. Non-uniform speed. So for all these, what are the SI unit means meter per second versus CGS unit means centimeter per second. So the speed now we have been said, which we can classify into average speed, instantaneous speed, uniform speed, non-uniform speed. So apart from this, we are going to discuss one by one. So in this, the first one which we are going to discuss, average speed. Here, average speed which we can write here as in simple manner in equation form as total distance by total time. So average, the name itself they have been given it as average speed, that which is nothing but total distance by total time. So with the help of this the definition which we can express here as it is a ratio of the total distance by total time taken between the two points. So in such a case we can get here as average speed. So for example, so we have been taken average marks. Average marks which is nothing but individual marks divided by total number of marks which we are getting as some average. In the same way, total distance by total time which we can be expressed. So next one is instantaneous speed. So instantaneous speed. The name itself they have been given instantaneous. So speed of a particle, or we can take it as object, speed of a particle at a particular instant of time, at a particular instant of time. At a particular instant of time. So for this example, as if I am giving average speed. So if you are taking, if you are riding a bike or car, so then what is the average speed per hour means we can tell 40 kilometers per hour. But whereas instantaneous speed, the speed of a particle at that particular instant of time. That means, for example, you have been started your journey from 8 a.m. to 9 a.m. Here overall average speed is 40 kilometers per hour. For example, we should have to know at this particular instant of time. So 8:30 a.m. we should have to know. In such a case, the speed of a particle at that particular instant of time, so we can tell here as instantaneous speed. So in general, here the average speed, so which we can tell here as delta x by delta, but whereas this instantaneous speed which we can express here as which is nothing but limit delta t tends to 0, almost a time which is equals to 0 but it is not equals to 0, that's which is nothing but delta x by delta, this one we should write here as, in case of like this, we should write here as dx by d. Here delta x is nothing but the total change in distance by, so delta t is the total time. So this is for long time, this is for small interval of time. In such a case, instantaneous speed we can write here as dx by d. So next one is uniform speed. Uniform speed. If a body covers equal distance in equal intervals of time, However, time interval is small. So, if a body covers equal distance in equal intervals of time, in such a case we can take here as uniform speed. In the name itself they have been given uniform. Uniform means same speed. So, if I have been taken like this, some of the points like this as A, this as a B, this as C, and this as a D. So if it covers equal distance, for example 10 meters, 10 meters, 10 meters and 10 meters. In a time period, for example when I am taking, so in 30 seconds, you can see that from A to B it has been traveled 10 meters in 30 seconds, 10 meters, 30 seconds, 10 meters, 30 seconds. So covers equal distance in equal intervals of time. So based on that we can take here as uniform speed. For this we have been drawn a graph. So that's time which we have been taking along. So x-axis which is denoted in terms of seconds, and then this which I can take here as a distance in terms of meters I have been taken. So which we are going to get it as a graph as like this. So uniform which we are going to get. That speed will be everywhere, it will be the same. That is, so which we can take for example 40 kilometers per hour means per hour 40 kilometers per hour which is travel. So next one is a non-uniform speed. Non-uniform speed. So if a body travels equal distance in unequal intervals of time, along a straight line. However, the time interval may be small. So in this case, we can take here as body travels equal distance in unequal intervals of time, or we can take here as if a body travels unequal distance in equal intervals of time. So for that, we have been taking a graph as like this. So which will be a non-uniform. That means it does not cover equal distance in unequal intervals of time. For example, I am taking here as like this: time, so and then distance. First, a time period 0 equals to 0, that it will be the 0. For example, I have been taking here as 5. Here distance is in terms of seconds, in terms of distance in terms of meter. For first 5 seconds, 10. So next for 10 seconds, it has been covered 15. Next for 15 seconds, it has been covered 25. Next for 20 seconds, it has been covered. So we shall take here as around 40 I can take. So for this we have been plotted a graph. So example, here the time, here the which I can take here as a distance. This is in case of time in terms of seconds, and this is a distance in terms of meter. So example, 10, 20, 30 and then 40. Here it will be the 5, 10, 15 and 20. For first 5 seconds it will be the 10. For next 10 seconds it will be the 15. 15 means which I will indicate as like this. Next for 15 seconds it will be the 25. 25. Next for 20 it will be the 40. That means you have been plotted this, which you are going to get approximately as like this. That which is not a uniform. So in example, if you have to tell means, so this is based on some values. Sir, I don't want values means you can take here as in simple manner as like this. So which you can take. So this is the time period in terms of seconds. This is the distance in terms of meters, which we can be considered. So this is regarding the non-uniform speed. Okay students, so previously we have been discussed regarding the speed and types of speeds. Now we are going to see some applications. So by using these applications, which we can do some numericals related to competitive exams. So first application, so which will be considered here. So if a body travels between 2 points A and B. If it covers half of the distance with speed v1 and next half of the distance with speed v2. Find average speed. So this we can write here as V average as an average speed. So with the help of this, I can tell here as first try to understand the application. If a body travels between 2 points A and B, or between 2 positions A and B, if it covers half of the distance with speed v1 and next half of the distance with the speed v2, or you can write it as if it covers first half of the distance also you can write, so nothing will be happening. So first half of the distance with the speed v1 and next half of the distance with the speed v2. We should have to find out the average speed. So from this we can take here as like this. So between 2 points which they have been given. So this is A and this is B. Here they have been mentioned first half of the distance. Half means midpoint I can take. So if this is the total distance, yes, then this distance is nothing but s by 2. This will be the remaining s by 2. First half of the distance with the speed v1 and next half of the distance with the speed v2. So then we should have to find out the average speed. So average speed. So average speed, which is equals to total distance by total time. So this is the formula which we have been discussed. Here the total distance is nothing but from A to B is nothing but yes, or s by 2 plus s by 2 is nothing but yes. Okay. Then what's the total time? Here they have been given in terms of speed as v1 and v2. So in such a case, with the help of definition, so speed is equals to distance by time. With the help of this, time is equals to right here as so distance by v. So I have to find for this the time period. I can take it as t1. For this time period, I can take it as t2. So t1 is equals to what is the distance? S by 2. So velocity is v1. Then we check it right here as s by 2v1, and t2 is equals to in similar manner I can write here as s by 2v2. So now I know the total distance and the total time. So with the help of this, which I can write here as that's v average is equals to so s by 2 plus s by 2 by time period t1 is nothing but s by 2v1 plus s by 2v2. Here we should not have to confuse. By taking LCM this s by 2 plus s by 2 we can get it as yes, and turning this s by 2 we should take it as a common. So s by 2 into 1 by v1 plus 1 by v2. Here ss which will be gets cancelled. This two will come in upwards direction. With the help of this, so v average is equals to 2 it will comes in upward direction 2 by 1 by v1 plus 1 by v2. By taking this as a LCM, v1 plus v2 by v1 v2. So v average is equals to so 2 by v1 plus v2 by v1 v2. So this final equation, so we can get here as which is nothing but I'm writing here. So v average is equals to 2v1 v2 by v1 plus v2. So that is the final equation, so which we have been written. So 2v1 v2 by v1 plus v2. Here most of the students which they confuse here, s by 2 plus s by 2 is nothing but yes. S by 2 by taking as a common, s will get cancelled, and then here by taking LCM we can get here as v1 plus v2 by v1 by v2. This comes in upwards. So with the help of this we can find the average speed. So example which I can take. So here this example I can take as later. So if you want to please make it stop and then you can copy. Here this is very very important. Half of the distance with v1, next half of the distance with the v2. So next one I can take here as say one more application. This is a similar formula which we are going to get. So if a body travels from A to B with a speed v1, and then body moves from travels also the body travels from B to A with a speed v2. Then find average speed. So if you have been understood the concept clearly, so which you can tell the answer. So what is the average speed? So if a body travels from A to B with a speed v1, and then body travels from B to A with a speed v2. So speed is a scalar quantity, so it does not consider about its direction. So that means I can consider this as A, and then I can consider this as a B. So A to B I can take this as like this distance is S, which it has been travelled with a velocity v1. In the same way, while moving in this direction, distance will be same and then velocity will be v2. So same, which I can express here as the same one as like that. So here I can take here as speed is nothing but distance by time. The help of this time is equals to S by V. Time period T1, how much time it has been taken? T1 is nothing but distance is S by its velocity as v1. For next from B to A, in order to move from B to A, so distance will be the same, yes, but velocity speed is nothing but v2. So by substituting that, which I am going to get it as a same. So with the help of this, which is nothing but, so V average is equals to, which I can get here as like this, total distance by total time from A to B. I can take here as yes, B to A as yes. So with the help of this, the total distance, which is nothing but yes plus yes, by, so T1 is nothing but yes by V1 plus yes by V2. Here S plus S, which is nothing but 2s by taking S as a common, 1 by V1 plus 1 by V2. So this, which is nothing but, so V average is equals to, so here SS will get cancelled. I can get here as the same formula. So 2 by 1 by V1 plus 1 by V2. Finally, by taking as LCM, I can obtain here as V average is equals to 2V1 V2 by V1 plus V2. So if you have been observed clearly, here they have not been mentioned, but A to B, how much distance is it? B to A also same distance. In previous case, we have been said first half of the distance and next half of the distance. So final answer will be V average is equals to 2V1 V2 by V1 plus V2. So please make it copy. So this is the basic applications. So in competitive exams they will ask based on this. So instead of 2 distances, they may ask 3 distances with speed v1, v2 and v3 also. So now I am going to tell one more application. So if a body travels between two positions between two positions A and B. If it travels first half of the time with speed v1, and next half of the time with speed v2, So then find average speed. Find average speed because I not have any space, that's why I am writing here. So this is the condition. So this is the next phase. If a body travels between two positions A and B, it will be the same. If it travels first half of the time with speed v1 and next half of the time with speed v2. So here I am considering same concept. So let us consider 2 points A and B. Here instead of in previous case they have been given distance, but now half of the time, this is a midpoint, this is t by 2, this is t by 2. They have been given the speed is v1 and the speed is v2. So but in order to find the average speed, so we know the formula. What's the formula? So total distance by total time. Total distance by total time. So here we know the time t by 2 plus t by 2. So and then they have been given v1 and v2. So but they are total distance. So from simple definition, which is nothing but speed is equals to distance by time. With the help of this I can write here as s is equals to v into t. So I am assuming this as s1, I am assuming this distance as s2. Now I can write here as s1 is equals to speed is v1 and time period is t by 2. v1 t by 2. Similarly, s2 is equals to v2 into t by 2. So v2 into t by 2. By substituting that values, here I can get here as, so total distance s1 plus s2 by t1 plus t2. So let us consider this is the t1 value, this is the t2 value. So I can substitute here as s1 is nothing but v1 t by 2 plus v2 t by 2 by t by 2 plus t by 2. With the help of this, I can get here as t by 2 as a common. So as if I am taking, so t by 2 as a common. So V average is equals to t by 2 plus t by 2, which I can get t by 2 into v1 plus v2 by, here bases are equal, denominators and numerators t by 2 plus t by 2 which are same, which is nothing but we can get here as numerators and denominators, so which is nothing but, so T we are going to get average. So we have taken as average as like this, T by 2 plus T by 2. Here denominator is same, we can get here as T, 2, T plus T, which is nothing but 2T by 2, which is nothing but 2 gets cancelled, we will get here as a T. So this T gets cancelled. So V average is equals to V1 plus V2 by 2. This is a one more application, so which they have been given. So these are the some applications, so based on average speed. Okay, my dear students. So thank you for watching, and please subscribe my channel and share to your friends. Thank you.